Are you having troubles to solve these algebraic functions? Well, this video is for you. Hi, I am Shikaina Alvernazor, a grade 11 student of SEM 3. So welcome to my video. So in this video, we will be talking about the different rules of differentiation that will allow us to compute for the derivatives of algebraic functions. Number 1, the constant rule of differentiation, which is from Theorem 7. So if c is constant and if fx is equals to c, for all x, then the first derivative of x is equals to 0. Our equation will be dx, the constant of c, will be equals to 0. For example, fx is equals to 9. So if we apply the constant rule, our answer to this equation will be 0. Second, fx is equals to 0. Therefore, the first derivative of fx is equals to 0. Second is the power rule for positive integer powers of differentiation, Theorem 8. So if n is a positive integer, and if fx is equals to x to the power of n, then the first derivative of fx is equals to nx to the power of n subtracted by 1. Our equation will be the derivative of x to the power of n is equals to nx to the power of n subtracted by 1. So for example, gx is equals to 7x cubed. So to get the first derivative of x, we need to multiply our constant first to the exponent being given. So therefore, we have 21 there in the bottom. And to apply the rule, we need to subtract 1 from n, which is 3. Therefore, our answer is 21x squared. Same goes with the second example, which is hx is equals to x to the power of 4. Therefore, our first derivative of x is equals to 4x cubed. Next is the constant multiple rule of differentiation. So, if f is a function, c is constant, and g is a function defined by gx is equals to c multiplied to fx, then if the first derivative of fx exists, then the first derivative of gx is equals to c multiplied to fx. So our equation will be the derivative of c multiplied by fx is equals to c times the derivative of fx. So for example, hx is equals to 7x cubed. So as you can see, our constant here is the number 7, and our fx here is x cubed. So we need to get the first derivative of fx first to solve for the answer. So our first derivative of fx is equals to 3x squared. Therefore, we need to multiply our constant to the first derivative of fx to get the answer of 21x squared. Next is the sum rule of differentiation, which is from Theorem 7, 10. So if f and g are functions, and if h is the function defined by hx is equals to fx plus gx, then if the first derivative of fx and the first derivative of gx exist, then the first derivative of hx is equals to first derivative of fx added to the first derivative of gx. So our equation will be the derivative of fx plus gx is equals to the derivative of fx added to the derivative of gx. So For example, hx is equals to 4x cubed plus 2x squared. So our fx in this equation is 4x cubed and our gx in this equation is 2x squared. So we just need to get the derivatives from fx and gx. Therefore, our answer to the first derivative of hx is equals to 12x squared plus 4x. Same goes with our second example, which is hx is equals to 3x to the power of 5 plus 2x cubed. So our answer will be 15x to the power of 4 plus 6x squared. So the sum rule of differentiation, which is the fifth one. The derivative of the sum of a finite number of functions is equal to the sum of their derivatives, if these derivatives exist. So our equation in this rule is just the same with the previous rule. For example, gx is equals to 8x to the power of 5 plus 3x squared minus 2x plus 4. So we just need to apply the rules. So therefore, we can have the answer of 40x to the power of 4 plus 6x minus 2. So as you can see, the number 4 in this equation is not seen in the answer because we applied the first rule, which is the constant rule. Number 6 is the product rule of differentiation. So if f and g are functions, and if h is the function defined by hx is equals to fx plus gx, then if the first derivative of fx and the first derivative of gx exist, then the first derivative of hx is equals to fx multiplied to the first derivative of gx added to gx multiplied by the first derivative of fx. So for our equation will be this: the derivative of fx multiplied to gx is equals to fx multiplied to the first derivative of gx added to gx multiplied by the derivative of fx. For example, hx is equals to 3x cubed plus 5x squared multiplied to 2x plus 4. So as you can see in this equation, our fx here is 3x cubed plus 5x squared. And our gx here is 2x plus 4. So all we need to do is this. We have to multiply our fx to the first derivative of gx and add it to gx multiplied to the first derivative of fx. Therefore, we can have the answer of 24x squared cubed plus 66x squared plus 40x. Next is the quotient rule of differentiation. So if f and g are functions, and if h is the function defined by hx equals fx over gx, where gx is not equals to 0, then the first derivative of fx and gx exists. Therefore, the first derivative of hx is equals to fx multiplied to the first derivative of gx subtracted by gx multiplied to the first derivative of fx over gx squared. So for example, our equation will be this: fx over gx is equals to gx multiplied to the first derivative of fx subtracted by fx multiplied to the derivative of gx over gx squared. So for example, hx is equals to 2x cubed plus 3x over 2x. So all we need to do here is we need to multiply first our gx, which is 2x, multiply it to the first derivative of fx, which is 2x cubed plus 3x, and subtract it to fx, which is 2x cubed plus 3x, and multiply it to the first derivative of gx, which is 2x. So therefore, we can have the answer of 8x cubed plus 12x over 2x squared. Next is the power rule of differentiation. So if fx is equals to x to the power of negative n, where negative n is a negative integer and x is not equals to 0, then the first derivative of fx is equals to negative nx to the power of negative n minus 1. Our equation will be this. the derivative of x to the power of r is equals to rx minus negative rx minus 1. So for example, fx is equals to 9x to the power of negative 2. So it is just the same with the power rule, but in this rule, our exponent here is a negative. So we need to multiply our constant to the negative exponent. Therefore, we have negative 18x. And from the exponent being given, we need to subtract it by 1. Therefore, we have negative 18x to the power of negative 3. Next is the chain rule. So if the function g is differentiable at x and the function f is differentiable at gx, then the composite function of f of g is differentiable at x. And the first derivative of f of gx is equals to f times the value of gx multiplied to the first derivative of gx. So for example, our equation will be this. The first derivative of f of g is equals to f multiplied to the value of gx multiplied to the first derivative of gx. So for example, hx is equals to 6x squared plus 7x to the power of 4. So as you can see, our fx here is x to the power of 4. The first derivative of fx is equals to 4x to the power of 3. Our gx here is 6x squared plus 7x, and our first derivative of gx is equals to 12x plus 7. So what we need to do here is we need to substitute x from our first derivative of fx from the value of gx. Therefore, we have 4 times 6x squared plus 7x to the power of 3. And we need to multiply our first derivative of gx too. Therefore, we have 12x plus 7. Therefore, we have the answer of 4 multiplied to 12x plus 7 times 6x squared plus 7x to the power of 3. So all we need to do is just substitute the value of gx to the x in fx. So that would be all. Hope that you liked the video and thanks for watching.